Hello physics lovers, welcome to PhyZiVibes. Today we are going to discuss a problem from Irodove, problem number 1.58. So problem says a solid body rotates with constant angular velocity omega naught 0.5 radians per second about a horizontal axis AB. At a moment t is equal to 0, the axis AB starts turning about the vertical with constant angular acceleration 0.1 radian per second square. Find the angular velocity and angular acceleration of body after 3.5 seconds. So the figure given in question is not actually of this question. So what you can consider the actual figure for this question is this. Now when they are saying that AB axis, so I have shown this AB axis on this figure. You can see this person is the eye which is looking is towards AB axis, and this disc is rotating with angular velocity omega naught 0.5 radian per second. And this about z axis, this body is rotating with constant angular acceleration beta naught 0.1 radian per second. So this is the problem. Now what we can do is let's see, one observer is looking this body from z axis. So you can locate a eye here. So this is person who is looking this body from upside, from z axis. So what he will find is, so this dot is representing z axis, this is representing x axis, and this is representing y axis. So as you can see from the figure, when this body starts rotating about z axis with angular acceleration beta naught, at that instant this body was along y axis, but after some time it would have rotated by some angle, let's say by theta, and at that point you will find this body to be somewhere here, and at that time this will be some scene. So this body is rotating about this axis with angular velocity omega naught, and by some time from z axis it has rotated by some angle theta, and this is z axis about which this body is rotating with constant angular velocity, constant angular acceleration given as 0.1 radian per second square, and this is angular velocity which is given as 0.5 radian per second square. Now you have to find angular velocity and angular acceleration of this body, net angular velocity and angular acceleration. So as we can see, this body is rotating. So what you can do is you can find angular velocity in vector form. So we have two angular velocities. One angular velocity is omega naught, about which this disc is spinning, and because of this angular acceleration along z axis, we will get one angular velocity along z axis as well, and this angular velocity along z axis will be the rate of change of this angle theta. So this will be the magnitude of angular velocity along z axis. Now we can represent this net angular velocity in vector form. So as we can see, this angular velocity omega naught can be resolved in xy plane. So when we will resolve this omega naught in xy plane, we will get omega naught cos theta j cap. This is component of omega naught along y axis at an instant. At t is equal to 0, this was totally along y axis. At t is equal to 0, theta was 0. But after some time, at some instant, this is angular velocity along y axis. Along x axis, we will get omega naught sine theta I cap, and we have one more angular velocity along z axis, that is omega z is the magnitude and k cap will be the direction. So this is our net angular velocity. Now what is omega z? So as body is rotating along z axis with angular acceleration beta naught, if you remember formula for angular velocity, that is omega is equal to omega naught plus alpha t. Here omega represent angular velocity, omega naught represent initial angular velocity, alpha represent angular acceleration. So this is basically our formula. If we put values in this formula, you will get omega z. Initially it was at rest along z axis, so omega naught in this formula is 0. Angular acceleration is given as beta naught and t is the time. So omega z is beta naught t. So when we put all these values, we will get omega naught cos theta j cap plus omega naught sin theta I cap, and plus instead of omega z we can write beta naught t k cap. So this is net angular velocity at any instant. Now we have to find magnitude of this angular velocity. So for magnitude we can take mode, and value of mode will be omega naught sin theta the whole square plus omega naught cos theta the whole square plus p naught t the whole square. So we know from vectors that if something is given in x, y, z, I, j, k format, so to find its magnitude we just take their square in under root and add them. So here what we'll get is, by solving this omega naught sin square theta, omega naught cos square theta, will get omega naught square as sin square theta plus cos square theta is 1, and from b naught t will get b naught square t square. So this is our result, and if we put the numerical values which we have been given as omega naught was given as 0.5 and beta naught is given 0.1 and t is given 3.5. So after solving this, what we'll get is, so on solving this we get omega is 0.6 radian per second, which is given answer. Okay, so now moving towards angular acceleration part. Now we have to find angular acceleration of this body as well. So we know that angular acceleration is defined as d omega by dt. Now omega we have already found in form of vector. So we will just simply put this value of omega and we will differentiate it. So omega is omega naught cos theta j cap plus omega naught sin theta I cap plus b naught t k cap, or you can say to be omega z k cap. Basically it was omega z k cap plus omega z k cap. So when we'll differentiate it, what we'll found is, now here omega naught is constant, so we'll take omega naught outside. Differentiation of cos theta will be minus sin theta, and we will get d theta by dt as well, and j cap. Omega naught is constant, differentiation of sin theta is cos theta and d theta by dt I cap, and differentiation of omega z. Now angular acceleration is omega minus omega naught sin theta. Now what is this d theta by dt? If you can remember, this d theta by dt is the rate at which this axis AB was rotating, and that was basically angular velocity along z axis, omega z. So instead of d theta by dt, we can keep omega z. Same way here also we can write d theta by dt is omega z. And what is d omega z by dt? This is the rate at which angular velocity along z axis is changing, and that is basically angular acceleration along z axis, which is given as beta naught. So it is beta naught k cap. So moving ahead, now the magnitude of this angular acceleration will be under root of omega naught omega z sin theta the square, minus is also there, plus omega naught omega z cos theta the whole square plus beta naught square. So solving this, we'll get omega naught square omega z square s sin square theta plus cos square theta is 1 and plus b naught square. Now what is omega z? Now using formula omega is equal to omega naught plus alpha t, and in fact we have already found this omega z. If you can recall, this is what we have found to be omega z. Value of omega z is b naught t. So instead of omega z, we will keep b naught t. So in next step, omega z is b naught t. So b naught square and t square, and plus b naught square is there. Taking b naught common, we will get 1 plus omega naught square and t square. Just by putting numerical values, that is, instead of beta naught we will keep 0.1. 1 plus omega naught was given as 0.5 and t is given 3.5. Solving all this, we will get 0.2 radian per second square. So while making this video, I made a small mistake. Please consider it. Here angular velocity is 0.5 radian per second, not radian per second square. So in unit I have done a small mistake. This is radians per second. So please consider it. So I hope you like the video. Please consider subscribing my channel. Please share and like the video. Thank you.